Okay, so kita start daripada awal. Try to recall all the topics in this course. Okay, the first one is chapter 1. Ni tak nampak. Apa dia? Ada ni ke? Okay, the chapter 1. Chapter 1, just introduction. You have Rolle's theorem, and then you have mean value theorem, and you also have Taylor series. Ya, dia macam ada seseorang yang bercakap ke? Okay. And in this chapter 1 kita ada apa? Kita ada uniformly continuous and so on. And then in chapter 2 kita masuk kepada multivariable function. Macam terbalik di ejaan tu. Multivariable functions. So in this multivariable functions, you define what is the domain and range. Same thing that you did in calculus 1. Okay, so what define domain and what define range? So you need to do that. And then also the same thing in calculus 1 for function, you define what does it mean by continuity. Functions, what does it mean by that? And you also, in these multivariable functions, just apply the same thing, but for more than one variable. So limits, and you also have epsilon delta definition for limit. And the most important thing in multivariable function is your partial derivative. Okay, so phi, not psi is in x, y, z variables, and then phi is x, depends on x, y, and z variables. Okay, you also, so this is the most important thing in multivariable functions, as well as the limit, but this is the most important things. And then you also have the tangent plane. This is what you are supposed to do in chapter 1, chapter 2. Tangent plane, and then chain rules. And you also have implicit function. So which means that chain rule, how do you find the derivative for multivariables? So for example, you want to find dx, not dx, yeah, dx, dy, not dz. If you want to find dz over dx, okay, and then x depends on u and v, and then you also have z, which depends on x and y, and then y depends on u and v. So that's the chain rule. How did you define chain rule? And you also need to find how to use the implicit function to find the derivatives. Okay, so as I go along this this topic, I hope that you try to understand, try to recall what you have been doing. So in this case, for example, you can use what do you call it as 3 figures. So z, for example, z, you have x, y, not z. Let's try to use another one. Maybe let's use q. Q depends on x, y, and z, and then x depends on u and v, y depends on u and w, z depends on v and w, for example. So let's try to recall what you need to be done. All right, and then we move to chapter 3. So for now, for those who just came, I just want to list out the topic. In chapter 3, you learn about Jacobian. Okay, how to define Jacobian. So for example, if you have this Q, and then you want to find the Jacobian of Q with respect to U or with respect to V and so on. And you also use the del notation, which is this. What does it mean by this? And what does it mean by this? So you need to know what's this, what does it mean by this? And then you also have the polar coordinate. So you need to know how to use the change of variable from Cartesian coordinate to polar coordinate. So actually chapter 3 is much more important for your multiple integral. So because you have polar coordinate and also the Jacobian. And the notation is usually used for what? Used for derivatives, directional derivatives, and also the gradient. And in chapter 5, so you jump from chapter 3 and then jump to chapter 5, which is how to find the extremum. You did, I think, this one in your quiz, or is it in your test? Find test number 2, find the extremum. You need to find the absolute. Same thing in calculus 1, absolute minimum or absolute maximum, or maybe you can find the minimum or maximum on the border. So that's between the region, neighboring region. And then you also, I think this is also important, you use Lagrange multiplier. Okay, I think that yes, this one is already from test 2, I think. Test, if I not remember, is it test or quiz? Saya tak ingat awak. Saya rasa test 2 or quiz 3. Try to look back. So this is in test 2, so you can see that Lagrange multiplier is not been asked yet. And then, so this is important. And you also have something compromised. Okay. Okay, so chapter 5 talk about extremum. What are the other method that you need to use to find the absolute minimum and maximum? So you need to know how to find it, how to define minimum or maximum. Okay, and then in chapter 4, which is quite long, chapter 4 talking about multiple integration. Okay, the first thing that we talk about is the double integration. So you have one is under rectangular region. And number two, you also have something like general region. And you also have triple integration. Same thing, you have either rectangle region or you have general region. So this is under S. This is S region. So double integration and multiple integration give you it can give you one is of volume. It can also give you the amount of work. So it depends on this formulation. So is it going to give you a volume, work, or power, and so on. And we also learn about line integration. I think line integration is in test 2, line integration. And this is related to Green theorem. So what does the relationship between line integration, between line integration and Green theorem? And you also, before we also have change of variables. So we apply chapter 3, which is the Jacobian, to find to define region. Okay, we use how did you apply the Jacobian to define general region and use it in change of variables. So I just simplify that, change of variables. Okay, any questions so far? So I just list out all the topics. And then in chapter 6, you have sequences and series. So sequences and series are not yet being in any of your tests, but it was in your quiz, the last quiz. Okay, so you need to know what gives this exponential value, the sequence of this that define E. And you also have the definition of infimum. You have the supremum. What does it mean by that? And related to limit superior and also limit of inferior. So this is related to what's the relation between this and this. Same thing for infimum. Okay, and then in chapter 7, chapter 6, and then chapter 7, actually this two chapter is correlated. You have the convergence of series. So in this convergence of series, you have last time we did 6, if I remember 6. but the absolute convergence and the alternating convergence is not in our, it's not in listed inside our topic, but that's for you to know. So you have test of convergence, test of convergence. You need to remember that the test of convergence is applied to series. Sequences is different. Okay, let's do some examples. I think I want to start from chapter 7, and then we can go to slowly from chapter 7 and then chapter 6 and so on if we have time. Okay, if you go to tutorial numbers 8, so let's pick out tutorial number 8. Okay, one of the questions looks something like this. Find the, let me see the exact wording of that. Tutorial number 8. Okay, so the question is find the formula for the general term UN of the sequences, assuming that the pattern of the first few terms continues. Okay, I think number A, 1A and B is quite easy, because you can see that 1 over 2, 1 over 4, 1 over 8, that is just 1 over n, and this is 1 over 2n, because this is just 1 over 2n. And also for number B, that is just 2 to the power of, no, sorry, I think the other way around. 2, or this is 2 to the power of n, and start from 1, and you can see that. And then for B, that is just 2n, so it's just even number, even fraction number. Okay, let's see, maybe C is also easy. C, you can see that the value is increased by 5, so that is like n plus 5, n starts from 2. Okay, maybe we can do a number D. Okay, let's try to number D. Okay, D says what? D says find the general term. So this is a bracket, not bracket, braces, minus 1 over 4, 2 over 9, and then minus 3 over 16, and something something. Okay, so you can see that this looks like something squared, and then you have alternating minus and then plus, minus and then plus. So you can see that the first term is minus, so you can say the first term is minus, should be n. So when n is 1, minus 1 to the power of 1 is minus 1. Okay, and I can see that this one, this is what? This is 2 squared. And this one is 3 squared. And this one is 4 squared. You can see that this is the power remain the same, but the only thing that different is the base, 2, 3, 4, and you expect the next term will be 5 squared. Okay, and then you can see that the relationship between the numerator, you can see that this one is 1, this one is 2, this one is 2, and this one is 3 and 4. So it means that the first term is 1, but the denominator is 1 plus 1 becomes 2. And then you can see that 2 plus 1 is 3. So my final general term will be, so it start from 1, and then it will be n plus 1 squared. And then this is n starting from 1 until infinity. So this is my answer for general terms. Okay, and then I don't think that tutorial number 8 has one question for series. I think most of the question are for sequences. Okay, but we can try. It's not a problem. Let's see. Let's see the convergence of sequence. Number 3, you can look at for number 3, tutorial number 8, and question number 3A. The question says check 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 the check if the sequence converge or not. So if you remember, the convergence of sequence, this is the easy part. If you know that the sequence is UN, so UN is the general term for the sequence, and you only take the limit as n goes to positive infinity for UN, and it goes to a finite number L. So it means that this sequence converge. So this is the easy part for sequence. For series, it's quite different. So you only need to take the general term to be finite. Otherwise, it will be diverges. Okay, let's see. Sequence for number 3A, 1 plus 1 over 2 to the power of n. All right. So if I rearrange this equation, this formula, the expression, I can say this is equals to 1 plus 1 over 2 to the power of n, because 1 to the power of n, and n is a positive number, so it will stay the same thing as 1. So if you take the limit as n goes to positive infinity, 1 plus 1 over 2 to the power of n, so this is equals to 1. Okay, so the series, the sequence converges. Number B, not number B, I think, is it B? Yeah, so B. So you need to apply your knowledge from limit in calculus 1. For example, if you have indefinite equation, for example, if you have 0 over 0, infinity over infinity, then you need to use L'Hopital rule. As can be seen in this one, you have log of 2n divided by log of 3n. So if you take the limit as n goes to positive infinity, log of 2n divided by log of 3n. Okay, so what do? So if you plug in, it will be indefinite fraction, because it will be something like infinity over infinity. So in this case, you use L'Hopital rule. So if you use that, and then make what did the L'Hopital says, you just derive into derivative, and after some manipulation, you can see that this actually equals to 1. So this is just, I don't want to, because we have more other question, we don't have much time to diverge, to indulge in this, so just use that. So finally the answer is 1. So actually this series also converges. Okay, any questions so far? So it doesn't necessarily be 1, but maybe 10 or 5, as long as L is finite. Okay, another one. Let's try to apply for exponential, using exponential to find whether or not the sequence is convergence. For example, in number 5, in the same tutorial, it was given that if limit of n goes to positive infinity, 1 plus 1 over n to the power of n is equals to e. So if you remember that we did derive this sequence, and e is between 2 and 3. So this sequence is converges to some value. All right. And the question is, let's try to find whether or not the sequence converge for this one, limit n goes to positive infinity, n plus 2 divided by n plus 1 to the power of n plus 1. Okay, so in separately, let's ignore the limit first. So in separate problem, if we take n plus 2 over n plus 1, n plus 1, so this is just equals to take the 1 outside, n plus 2, and then n plus 1. This is to the power of n times n plus 2 over n plus 1 to the power of 1. Okay, and then the same, we take only this part, because from your definition, limit definition, if you have limit, let's say x goes to a for, let's say, f times g, so this is the same thing as you take separately limit x goes to a of f times limit x goes to a limit x goes to a for g. So we can use the same analogy on this sequence. Okay, so first of all, what's the limit for n goes to infinity for n plus 2 divided by n plus 1? So you can see that this is n to the power of 1 is dominant in this thing, and the coefficient is 1, so this is just equals to 1. Okay, so you don't have to worry about this one. no worries. So that one is 1. And we need to worry about this one, the limit of n goes to positive infinity, n plus 2 divided by n plus 1 to the power of n. Okay, you can see that now we have the same power. This is n, and this is n. But the problem now is that this one is 1 over n, but that one is n plus 1. So if I separate this, if I separate the using partial fraction, okay, I can say that this is just equals to limit of n minus infinity 1 plus 1 over n plus 1. Okay, any questions so far? That's quite straightforward, right? So what to do about this? So if you apply, what to apply? Apply that the exponential of log 1 plus 1 over n plus 1. I believe that you already learned this. Okay, apply this and plug inside this, and this actually equals just e. All right. Now let's look at chapter 6. I think chapter 6. Yes, chapter 6. Not chapter 6. This is chapter 6 and 7. What we did, sequences and convergence of series. Unfortunately, for those maybe just came, I couldn't find any question on tutorial for series. So therefore, please do on your own. Try to find any question relating to test of convergence. So maybe you can ask later on. Also we did for chapter 7 and chapter 6, and let's look at for chapter tutorial number 7. Okay, tutorial number 7. So tutorial number 7, if you look at, I think the most of them are the same, except let's look at for what? For I think it's number 8 or something. Let me see. Okay, most of the question are about gradients, and then extremum, local extremum, absolute extremum. So I think you can try that on. Okay, and then you have also number 8 until number 8 until number 11. You can see that the question is regarding Lagrange multiplier. Okay, so let's try to do number 8. Right, number 8. Why I say Lagrange multiplier? Because when you see some question, something like restriction or condition on to find the extremum, it will give you 2 functions. Okay, let me see again. The question is about what? So find the extremum. So question number 8 says that find extremum for x squared plus y squared plus z squared and restricted by the condition with the condition with condition 3x minus 2y plus z minus 4 equals to 0. So in this case, usually some kind of question like this, we use Lagrange multiplier, which is, what does it say? So if you have del, the gradient for f is just the same thing as you have some kind of constant times the gradient of the condition. So I think that your previous lecturer already explained to you about this. So the gradient is just like a different constant, but on different constant. The gradient is the same, but it located on different line. Okay, so what's the f? So let's see, if we define f is the equation for x squared plus y squared plus z squared, and then I define g is the function for 3x minus 2y plus z, and this is equals to 4. Okay, so this is just g is the constant 4 with so what's the gradient of f? The del f, so this is just equals to 2x and then to y and then to z. So please be careful also z and 2, because sometimes you can be confused if you didn't put the horizontal line on z. So 2 and let's say the z. So try to differentiate between 2 and z. So that's why I usually put the horizontal line on z. So to differentiate between 2 and z. And then you have g, the gradient of g, which is 3. And then in y, this is 2. In z, that is just 1. Okay, any questions so far? Okay, so f is just lambda. So if we compare the first term and for the term for f and g, so we have 3 equations. So we have 2x equals to lambda times 3. That's awkward. Let's use 3 lambda. And then number 2, we have 2y equals to minus 2 lambda. And then number 3, we have 2z equals to lambda. And then we also have the condition that number 4, which says that 3x minus 2y plus z equals to 4. Okay, and then I think that solve for plug in, I don't want to solve this, plug in lambda. Yes. Plug in lambda, then you can find your equals to something. And then you can also have the x, y, and z coordinate. And that is the extremum. Is it minimum or maximum? I don't know. It can be minimum or it can be maximum, because you can see that the value is single value. Lambda is only one value. It can be minimum or it can be maximum, but it definitely extremum. Okay, and let's see. We go on to tutorial number 6. Any question so far? Tutorial number 6. So tak ada soalan.
The question ada.
Tak ada. Tutorial number 6. Tutorial number 6. Let's see the multiple integration. Question number 3. Kalau saya cepat sangat, let me know if I can slow down. Okay, so the question is asking find or maybe evaluate triple integration for region E, 6xy dv under the plane of z equals to 1 plus x plus y bounded by y equals to square root of x, y equals to 0, and then x equals to 1. Okay, now first thing first, you don't have to sketch, but it is better to sketch because when you sketch your region, it's easy to see what kind of region that you are going to evaluate. Okay, let's see, bounded by this. So if you look at from above on y and x and y coordinate, okay, and you have, this is y, this is x. X equals to 1. So x, let's say this is the line for x equals to 1. Okay, and then we have y equals to 0. Y equals to 0, so it will be this line. And you have y equals to square root of x. So it will be this line approximately, something like that. So this is y equal to square root of x. This is x equals to 1. And this is y equals to 0. So the region is inside this region. So this is the region E. Okay, and then under the plane x plus y plus 1. So I think it's hard to see in this. If you can try, you try to plot this in 3D plots. You can see that this is above the positive xy plane. So this is located above the xy plane. And z will start from 1 until something given in this region, all right? X and y. Okay, so the first thing, you need to define the boundaries. Boundaries for integration. Okay, let's see. Which one we want to fix, meaning that it should be a constant from A to B. It's not a function. The boundaries is not a function. So I think that I like to fix x, meaning that I can take the value x, somewhere value x right here, and then being a constant, x goes from 0 until, and then leave the curve square root of x, y this on, and then I also can take right here and then live on that curve. So for any value on x-axis, dekat mana-mana je dekat x-axis ni, saya akan masuk start daripada kosong, enter y equals to 0 and then exit at y equals to square root of x. So that is constant. The same thing. So it doesn't change. Same thing kalau saya nak buat kat sini pun boleh juga. If I want to start from here to there, this is also okay, no problem. But I think that is better. Bagi saya nak guna x sebagai constant. So I can say that, I can say x enter from 0 at starting. I start at 0 and then I ended at x equals to 1. Faham ke apa yang saya nak sampaikan? Dia punya ni.
Faham.
Faham Okay, so saya nak cari boundary. Sebab apa? Bila boundaries ni saya nak letak dekat saya punya integration. Okay, and then y. Untuk y start daripada mana? Y start from here, daripada kosong sampai y equals to x. So y start from 0 to y square root of x. That's quite easy. So this is the boundaries for y. So y start from here until enter at 0, exit at. Enter at here and then exit at. So it start from 0 until y equals to square root of x. And how about z? So z is correspond to the boundaries in x and y. So you can see that z equals to 1 plus x plus y. So when x starting from 0, x and y and x start from 0. So you can see that z equals to 1. Z start from 1. And then when x, y, and x end at 1 and square root of x, you can see that z equals to 1 plus this one. Okay, so that will be 1 plus 1 plus square root of x. So this is equals to 2 plus square root of x. So you can see that z start from 1 until 2 plus square root of x. So in this case, you don't have to use change of variables because this is the general is quite easy. So you can see that we need to plug into the triple integration. So 6x, y. So the inside, you can say that the inside, it's easier if you put z inside first, dz, dy, and then dx. So z starting from 1 until 2 plus square root of x, y starting from 0 to square root of x, x starting from 0 to 1. Okay, so then you can evaluate on your own. So you can solve this. And this is quite easy to solve because this is just a multiplication of x and y. All right, so I don't think that I have I have time for the next tutorial, but I think that tutorial number 5. So tutorial number 5 is all about Jacobian, change of variables. Try to practice on that. And you can go until tutorial number 1. Okay, so I have some requests about apa di request ni? Brief about final exam. Okay, so final exam, your final. I think, let me see the schedules. Final awak bulan. Okay, final is on Thursday. July 15. The time will be 2:30 until 4:30. Okay, so the rules. Rules is open book. Open book, internet. But close discussion. So I advise you, please do not plagiarism. Please do not copy from your friend, because if I see some similarities, because I can detect similarities between your answer. Okay, so and then I will give you immediately 0.